All right, so welcome to another lecture for linear algebra. Today we're learning about matrices, some super basic things. For example, we hope to learn the basic definition of a matrix, how to add them, how to multiply matrices, and maybe how to do scalar multiplication of a matrix. So first things first, a matrix. Really, a good way to think about a matrix is a table with entries. Um, that's it. That's pretty much a matrix is. It's a table with numbers or entries. They don't always have to be numbers. They could be functions. They could be matrices. They could be cats and dogs. They could be anything. It's just the defining features is the fact that it's a table, meaning that it has a certain number of rows and a certain number of columns, and the entries are lined up as they would in a table. For example, here's a simple example. Suppose I have a table here with few numbers 2, 3, 5, 1, 0, -1. This would be a table of numbers. And these numbers all happen to be integers. These are all integers. If you remember from our last lecture, the symbol for integers would be this fancy Z. This also happens to have, let me see, 2 rows. And it also happens to have 3 columns. So one way to think about it, a short way notation is that let's call this number A, this matrix A. It's customary to refer to matrices using a capital Roman letter, like we'll call this A. This is a matrix A. A is equal to that. A fancy way to encapsulate all of this, the fact that it's got integer coefficients, integer entries, it's got 2 rows, and it's got 3 columns. A fancy way to encapsulate all of that and the fact that it's a matrix is to just say we would say something like this. A is an element of the family of matrices that are 2 by 3, meaning they have 2 rows and 3 columns. That's where you get this 2, 3. The first one is the number of rows. The second one is the number of columns. The M stands for matrices. The E here means element of. So we're saying A is an element of the collection of all matrices that are 2 by 3 and that have integer entries. So I could finish it off and say this is all matrices. This A is a member of the collection of the family of matrices that are 2 by 3 that have integer entries. Also, you could say get a little bit fancier and say the collection of all 2 by 3 matrices that have integer coefficients is really just a subset of the collection of all matrices that are 2 by 3 that have real number entries. Why? Because anything that is an integer is also a real number. So all of this would be contained in that bucket. This is a much, much larger bucket. So, and also there's the number of rows and number of columns could be any whole number. You could have a 1 by 3 matrix or 3 by 1. So let's say, or 1 by 2, for example, or 2 by 1 here. So we could have x and x squared plus 1. That right there is a matrix. And this would be an element, let's say P is equal to all polynomials. Let's just say that P is this collection of all polynomials with x as x variable. Okay, then I could say that this is a collection of member in the set of all matrices that are 2 by 1 that have polynomial entries. So this would be another example. That's how we define matrices, and that's the common notation. Okay, next, we want to learn how to add matrices. This just gives you a summary of what I just said. This is an m by n. Of course, the n is the number of columns. That's the second number. The m is the number of rows. The entries here, they all get named. For example, the A2 entry, sorry, the A23 entry, it's named that way because it's the entry on the second row, third column. This one, on the other hand, is the entry that's on the third row, first column. That's why it's called A31. So that's how we name every individual one of these entries. That's how you name the matrix. That's what we just got done doing. Matrices. What we want to do is define addition on these matrices, though. How do you add things in the matrix? Well, I guess that most of you are here and you've already taken calculus, which means you've already taken basic algebra, whatnot. So chances are you already know how to add matrices. But just in case, here's how you, in case you haven't, or in case you aren't from around here, I'll tell you how to do it. It's super, super simple. It'll take me like 5 seconds to show you how to do it. The thing to note here is that we only add numbers that have the same dimension. 2 by 2 can only be added with a 2 by 2. And of course, the same sort of creature inside here, because you got to add those creatures. So if these are real numbers, I got to be able to add real numbers. So you can't add real numbers in something that doesn't add with real numbers, like colors, for example. You can't add 2 plus red, but you could add 2 plus 1. So as long as you have the same, these are compatible, we could add them. And the way we're going to add them is real simple. All you do is take the 1, 1 entry and the 1, 1 entry, and you add them, and you get 3. Then you get the 1, 2 entry and the 1, 2 entry, and you add them. And so on and so forth. You add the 2, 1 entry, and then you add the last entry. And that's how you add matrices. Can't believe I get paid to do this. Insane amounts of money to do that. You add them, what you would call this is you add them component-wise. Okay, that's how you add them. You might also have had experience adding stuff like this when you added vectors. I'll give you another example. Back in trig or some other class, you might have added vectors like 2, 3, 1, added to 1, 1, 1. You could add these two, and again, you add them component-wise. Real simple like this. So the addition is super, super basic. The addition element, or sorry, the identity element is 0. So for example, if I have 2, 1, 1, 1 added to 0, 0, 0, 0, I'm guessing nothing's going to happen to that first matrix. I'll get 2, 1, 1, 1. So that guy right there is called the additive identity. Additive identity. In the world of matrices that are 2 by 2 that have real numbers. Okay, that's the additive identity. Doesn't change anybody. Okay, that's how you add. Multiplying is a little bit more complicated, but not that much. Again, I'll go through it, assuming that most of you have seen it once or twice in your life. So the way you add them is you first look at you go by rows by columns. This is how we multiply the row. We multiply this row by this column. That's the first thing you got to do. So if I multiply this row times this column, and the way you do it is you do it using what you might have done before, the dot product. You get the 2 times the 1, that's 2, and then 3 times the negative 1, that's negative 3, and add it together, that gives you negative 1. And so I'll make a little think bubble here for the first entry. I'm doing 2 times 1 plus 3 times negative 1. And of course, that's going to give me negative 1. That's my first entry. For the next one, I'll take the same row times the other column. It's always row times column like that. And you're doing dot product. You might have done dot product before, like in a trig class or something like that. So for the dot product for these two, the first thing you would do is you take the 2 and that 2, that gives you 4. The 3 and the negative 5 gives you 15. So I'll make a little thinking bubble here to show you what I'm thinking for the second entry in the first row. 2 times 2 plus 3 times negative 5. Okay, so I'm thinking 4 plus negative 15. Okay, and so on and so forth. The next one, that's the first row of the product. For the second one, I'm going to use the second one times that, and the second one times that, and those will be my entries that go here. So the first one I do that. I'm not going to make a thinking bubble right now. I'll just think out loud. That's going to be -1 and a -4. So that's going to give me a -5. And then I'm going to do a negative that times that. I'm going to be doing it in my head. That's going to be -2 and -20. Okay, that's it. That's how you multiply matrices. Okay, the other thing you got to note about multiplying matrices is that they don't have to be the same size to multiply them together. You could multiply things that are like this. You could multiply a 2 by 3 times a 3 by 2 matrix, such as these ones. The thing you got to watch out for is just the only number that has to match is this one. This one, the number of columns on this one must match the number of rows on this one. So as long as these two match, you'll get a good, they're compatible. And the resulting matrix will be this size, whatever this number is, by that number. That will be the result. So in this case, if I multiply these two, I'll get a 2 by 2 matrix. Okay, and the way we're going to do it is very, very similar to what we did before. Just take rows times columns. First, I'm going to do this row times this column. And I'm going to do it using the dot product, and I'll do it in my head. So I'm going to be taking that 2 times that 2. That's a 4. I'm going to take the 1 by that. That's a 3. I'm going to take that by that. That's a -4. So I'm going to be thinking, for the first one, I'm going to be thinking 4 plus a 3 plus a -4. That's going to give me a 3. So that's my first entry right there. Okay. Next, I'm going to be doing row times column. So I'm going to be multiplying the 5 by the 3, the 3 by the -1, and the -1 by the 0. And I'll add all of them up and see what I get. I'll write something here just to make sure we're all on the same page. This will give me a 10. This will give me a -3, and this will give me a 0. That's going to give me a grand total of 7. And so on and so forth. I'm going to multiply this one dotted with that one. That's going to be a -2 and a 4. That's going to give me 2. So this is going to give me 2. And then finally, I'm going to do this one times that one. That's going to give me -5 and a -4. That's -9. Zeros are going to kill each other. So I reckon I'm going to get a -9 here. And that's it. Now notice what happened here. Keep an eye on the dimension. As I said before, to be compatible, these numbers must match. And of course, these things have to be compatible too. You must be able to multiply them. But these numbers have to match the inner ones, and the result will be the outer ones, the 2 by 2. So in here, we have a 2 by 2 matrix as promised. Okay, that's how you multiply them. Now, I should mention maybe a larger, I don't know, you might think sometimes it's, if you're a beginner, you might wonder, why the hell would you multiply matrices that way, right? I wonder that sometimes. Or is there a more broader point of view that you can take to see what the hell we're doing here when we're multiplying them? A good way to think about it is, I think, well, here's another way to look at it, okay? For the first row, the 2 and the 3 here tell me that I'm going to take 2 of these ones and 3 of those, and I'm going to add them together, and I'm going to replace them right here. That's what it's saying. 2 of the first rows, 3 of the second rows, and I'm going to combine those guys. Is like making a mixture of the top row and the second row. I want myself a mixture of this and this. Like when you go to the store, I want 2 tomatoes and 3 oranges, whatever. I want 2 of these and I want 3 of these, and I want to combine them and put them here. Let's think that through thoroughly. So if I want 2 of these ones plus 3 of these ones, that would give me, that's the same thing as saying 2 and a 4 plus a -3 and a -5. That's a -1 and a -1. So this is -1, -1. That's what it's equal to if I was to combine 2 of these plus 3 of those. All right. Of course, I did it wrong, but that's okay. Negative 3 should be negative 15. Don't worry about that. Details. Okay, okay. The other thing too is, of course, if you wanted to do this, that's telling me that I want negative 1 of these rows and I want 4 of these ones. So the way you'd cook that up is, okay, I want negative 1 of these ones plus I want 4 of these ones. That would be negative 1, negative 2 on the top, and that would be negative 4 and negative 20 on the bottom. If I add them, it's going to give me negative 5 and a negative 22. So this is going to be negative 5 and a negative 22. This would be another way to think about it. It's a much broader, more deeper way of thinking about multiplication of matrices. If you wanted to do that, same thing here. This is saying, hey, I want this many of these ones. I want 2 of these. I want 2 of these, 3 of these, and negative 1 of these. And I want you to put them there. Perfect. This one is saying I want negative 1 of these, 4 of these, and 0 of these, and put it here. And that's what that thing is doing. Okay, so that's just a slightly broader point of view on matrix multiplication. Of course, the identities are easy, and these identities will work for, they're usually just referred to when we have square matrices. Square means the number of rows and the number of columns are the same. This is the additive identity. It doesn't change anyone when you add to it. This is the multiplicative identity. It won't change. It won't change anything because it'll just take one of the first row and one of the second row, so it'll just leave it alone. That's vocabulary. Pretty much all the things that we learned before about integers, commutativity law, associativity law, all these all work except commutativity law of multiplication. This one will fail for matrices. Okay, it will fail miserably. And also inverses. Not all our matrices will have multiplicative inverses. Some of them you just can't invert them. So a couple little things to watch out for. This one may fail sometimes. This one may fail sometimes. All the other ones, good to go. Okay. But amazingly, with some of those failing, some of these theorems will also fail. It'll cause them to fail. So you have to be super, super careful. So whatever you did in algebra class here does not necessarily translate into matrices, which means you got to be extra cautious. Okay. Okay, let's pause here for a second.